Okay, these two properties here, it's been a while since we've seen these, but we've seen these over and over again. Number 2 probably should be a little bit more familiar to us than number 1. But on number 1, if I tell you that RU is congruent to WX, WX is congruent to YZ, then RU is congruent to YZ. What property are we using there? What'd you say, Adrian? Transitive. Good job. That is the transitive property of congruency. A transitive property takes two pieces that those two statements have in common. They're both congruent to WX, so because they're both congruent to WX, then we can determine that RU is actually congruent to YZ. Okay, so if they have a common piece, we can link that common piece together and make a third statement. So that's how we recognize the transitive property. Two statements combined together to make a third. We've seen that a lot, off and on, throughout the semester. Maybe it's been a little while since we've seen it, though. Okay. Angle A is congruent to angle A. When I have exactly the same thing on both sides of my statement, that tells me what? Reflexive. Okay. We see that a lot of times with sides. But here it's with an angle. And we actually did a proof last week where we saw a shared angle like that. And so we might see an angle being used every once in a while, but probably more often it would be like AC is congruent to AC, where they have that shared side. Okay, so today, what we're going to talk about is if we have congruent triangles. Okay, if we have congruent triangles, and that's what we've really been focused on for the last week or two, is we're trying to figure out, are these triangles congruent, yes or no, and why can we prove that they are? Well, today, what we're going to do is we're going to prove the triangles congruent. Now, if two triangles are congruent, what do we know about the pieces of those two triangles? Okay, they're all going to be congruent, right? So how many total pieces do two triangles have that are congruent? We have 6 pairs, right? 3 sides and 3 angles. So we have 6 total pieces. We use 3 of those pieces to prove the triangles are congruent. Once we've proved they're congruent, then we know the other 3 pieces will be congruent. Okay? So that's what this theorem right here is saying. Okay? And we're going to use a shorthand for this. So C I'm just going to write it out here. Corresponding parts of congruent triangles are congruent. Okay, so what we're essentially saying is, if two triangles are congruent, all the corresponding parts of those two triangles are congruent. So we call this the CPCTC. Corresponding parts of congruent triangles are congruent. We don't do anything with the of and the are, but that's our shorthand. We don't want to have to write that out every time. That would be not a lot of fun, right? So we're going to use the CPCTC to get there. As far as the proof goes, all we're going to do is add one more step to the proof. Okay? We're going to take the proof that we've been doing for the last couple of weeks, and we're going to add an additional step at the end. Because if we look at this first example here, first proof, they've got the 2 columns ready to go for us. Notice the statement that we're trying to prove. We are not trying to prove the triangles are congruent. We're trying to prove these 2 sides are congruent. I'm trying to prove that QT is congruent to ST. I'm going to redraw it so it's maybe a little bit easier to see. I think it's kind of hard to see within that. Okay, so here we have Q, R, P, and T. Or S, sorry, this is S over here. Bryson, you need to quit talking, please. All right, angle 1 and angle 2. This is really hard to see in here. Angle 1 is labeled in here. This is angle 1. This is angle 2. Okay? There's a little arrow in there that's pointing to those two angles, and I know it's really hard to see. We could zoom in a little bit, and there is a little arrow pointing it in there, but that's what it's talking about. Angle 1 and angle 2. Okay? We also know that angle RTQ is congruent to angle RTS. Okay? Now, we got to follow the path of the letters here, guys. And I think some of us are doing a really good job of this, and others are kind of struggling with which angle we're really talking about here. But if I say RTQ, just follow the path of the letters here. RTQ. RTQ is this angle right here. RTS is this angle right here. Those two are congruent because they're given to me. Okay, so as we look at these two things right here, then how many pieces do we have? 2, okay? How many pieces do we need to prove triangles congruent? 3. Okay? So we need one more piece to prove that these two triangles are congruent. What else do we know about these two triangles that we can prove congruent? Okay? RT and TR are congruent. I can say RT is congruent to RT. I can say TR is congruent to TR. I can say RT is congruent to RT. Or RT is congruent to TR. There's so many different ways I could say it, but they all mean the same thing. We're talking about the two sides that are shared. RT on this triangle is the same as RT on that triangle. They share that side. And we've talked about this over and over again, that this is almost like a given. If two triangles share a side, then we're going to use that almost every time. Why wouldn't we use it? In most cases, because we know that they're congruent. Okay, so that gives me a third piece. Is that enough to now prove the triangles are congruent? Well, let's look at what we have. What kind of piece do we have here? We've got an angle, and a side. Is that one of our theorems that we can use? Yeah, okay. So now here's the part where you have to do this on your own. We haven't had to really do this a whole lot. We got to identify the two triangles. So I'm going to go Q, T, R. And you can start in any order that you want to go in. I'm starting down here with Q. Q, T, R. Is this triangle right here. Okay? I chose to start with Q. You could have started with T or whatever letter you want to start with. Okay, now what letter would Q match up with on the other triangles? S, okay, because they're marked the same. So we're going to say triangle S, T matches with T, and then R matches with R. We got to make sure that we rewrite that in the same order. Order is going to be really, really important. We've talked about that over and over again. And we already identified the three pieces that we have are in an angle-side relationship. This is where we stopped every other proof that we've done. Okay, we hadn't gone any farther. We proved the two triangles were congruent, and then we stopped. Well, now today what we're saying is, if these two triangles are congruent, why would QT and ST be congruent? Well, what do we know about these two triangles now? The two triangles are congruent. So if the two triangles are congruent, what do we know about all their parts? They're also congruent, okay? So here's what we're going to say. QT is congruent to ST because of our new theorem. Okay? So here's really what you need to know. If we're trying to prove two triangles are congruent in our proof statement, this is going to be one of our triangle proof theorems. Angle, angle, side, side, angle, side, 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 one of those. If we're trying to prove triangles congruent. If we're trying to prove sides or angles congruent, we're usually going to use the CPCTC as our last step. Okay? So you got to identify what it is that we're trying to prove. Okay, questions on that one? We're probably not going to do all of these examples today. I'll probably skip over a couple of them. Let's go to this one here. Prove that angle A is congruent to angle C. Okay, I want to prove that these two angles are congruent. Okay, one thing that I've told you is sometimes the given is stated out, sometimes it's marked, sometimes it's both. Sometimes they tell us and they mark it. In this case, all they did was mark it on the picture. So what we know here, based off of the picture, is that AD and CD are the same, right? They're both marked the same. So I'm going to say AD is congruent to CD. I can also say AB is congruent to CB. If you want to put that in two separate steps, you can put it in two separate steps. I like to just put it all in one step because all of that is given. So we're just going to do one given step. On the proof packet last week, they separated those into two steps, and we don't necessarily have to do that. Okay, so right now, how many pieces do we have marked as congruent? 2, okay? And we always need 3. Have to have 3. 2 is never going to be enough. Okay, we got to have 3. So I got to find one more piece that is congruent on these two triangles if I were to separate them. What other piece would we be able to say is congruent here? BD is congruent to BD. How come, Xander? Reflexive property. Okay? We see that over and over and over again. I can't stress that enough. If they share a side, we're going to use that 99.9% of the time. It's almost like a given statement. It should be, I mean, we've talked about that so much now that it should be coming second nature to you, hopefully. Okay, do I now have 3 pieces? Okay, and then we've got to figure out, are these 3 pieces enough? So here we have a side, side, side. Is side, side, side a theorem that we have? Yeah, so we can use it, right? Okay, so here we're going to identify the 2 triangles. So over here, which letter do I have to start with? Doesn't matter. I can choose A, B, or D. I don't care which one you do. A lot of people like to go alphabetical and go A, B, D. But you don't have to. You could do B, A, D and make it a bad triangle, right? Doesn't matter what order you go in for that first triangle. You do that any way you want to go. So I started with A, B, D. But then when I identify the second triangle, I have to match up the pieces on the other triangle that match up with A, B, and D. So A is going to match with C across on the other side. B is going to match with B, and then D is going to match with D. Okay, this one went A, B, D. This one's going to go C, B, D in that order. And that reasoning here would be side, side, side. This is what we're trying to prove. Whatever we're trying to prove has to be our last statement. So if it said, let's prove these 2 triangles congruent, we'd be done. But it doesn't. It says, let's prove angle A is congruent to angle C. What are we going to have to use here? How are those 2 angles congruent? because all the sides are congruent, okay? And if we know all of the sides are congruent, we know the triangles are congruent, and if all the triangles are congruent, what do we know about all the angles? They're all congruent. So I can prove any of those angles at this point now. What am I going to use for my reason here? We're going to use our new statement, right? If the two triangles are congruent, and that's what we've done right here. We've proven the two triangles congruent, right? We know the triangles are congruent now. So because the triangles are congruent, I could prove any of those angles being congruent. I would know these two are congruent. I know these two are congruent. I now know those two are congruent. Any of those pairs of triangles in those two triangles are congruent, okay? They're all congruent. Okay, on this one here, I'm not going to necessarily do a two-column proof. We could do a two-column proof, but unless it says write out a two-column proof, this one just says explain why. So you could write it out in a sentence. You can do it in short statements, however you want to do it. So I'm going to show you another way that you could do this. I'm going to redraw this picture here. Okay, here's my picture, and maybe don't necessarily have to do that. Okay, we place a stake at K. Basically what we're doing here, and one of the things that we can do in geometry is we can use different things. Like, if we're trying to find the length across this, this river, okay, or whatever we got here. And if it's really far across, maybe I can't just take a tape measure and string it across there and say, here's the length of how far wide this river is at this point, okay? So I'm going to have to go about it a different way. One of the things we're going to do a lot in the second semester is we're going to go through and find different ways of measuring things that are otherwise maybe going to be hard to measure. Maybe the height of a really tall building, or in this case, trying to find how far across is it from M to P. Okay, so it says that we're going to place a stake at K on or near the side so that NK and NP are congruent. Not congruent, but perpendicular. Okay, so we know that these two are going to be 90-degree angles. So I'm going to say something like angle N is congruent to angle K by the definition of perpendicular. Okay, then it tells me M is the midpoint of NK. So we're going to say NM is congruent to KM. How come? Definition of midpoint. Okay? If we know it's the midpoint, we know those two pieces are congruent because we know the point is right in the middle of those two. How many pieces do we have right now? Two. Okay? What other piece of information do we know about these two triangles? What's another piece of information that we can use or we can prove without really being told that it's congruent, other than the reflexive property? And yeah, so it might tell me that you might think this is the midpoint, but does it say anything up here about M being the midpoint of LP? No. Eventually that's where we're going to get to, right? But right now we don't know that to be the case because we can't find the length of this across the river because we don't know how long it is. We can't just go in and measure it. When two triangles meet at a point, what are those two triangles going to form? What do we call these two? Vertical angles, right? So we can say that angle KM L is congruent to angle NMP. Make sure that M is in the middle, because M is the angle that we're referring to, because vertical angles are congruent. Okay, how many pieces do we have now? 3. Okay, so these two triangles are congruent, so I'm going to say triangle NMP is congruent to triangle KML. And then we look at the pieces that we have. We got 3 pieces. Okay, what do we got down here? Okay, and K is a right angle, so it's an angle, and then we have a side, and then we have angle. That's why we must mark it on our picture, guys. If we mark it on the picture, is it really easy to kind of just follow the path of those parts? If I don't mark it on the picture, that's going to be really, really difficult to do. So what I'm seeing is some of you guys aren't marking it on your picture, and then you're trying to figure out which theorem am I using. Okay? If you don't mark it on the picture, then it's going to make it really difficult to decide if I'm using side or angle side angle or what I've got. Mark the pieces on your picture, and then all you got to do is say, I got an angle, a side, and an angle. The side's between the 2 angles. And so therefore, these two are congruent because of angle side angle. Okay, so the question there now is, if I wanted to find the length across the river here, what would I need to do? What could I do to find the length from M to P? Is there a length that I could find? What length would MP be the same as? Look at the 2 triangles. What would MP be the same as? Okay, what's K? KL is this one down here. So KL is going to match with MP, right? So we're trying to find the length across the river from M. M, yeah. ML, right? So could I actually measure ML since it's on ground? Could I measure the distance from N to L? Yeah? This one's going to be really difficult to do. But if I measure the distance from M to L, then I know the distance from M to P would be the same. Okay? So MP is congruent to ML by CPCTC. So we measure LM to find MP. A lot of times when we do this, we're just saying that those 2 pieces are congruent. But this would be kind of more like a story problem. When would we ever use congruent triangles? Well, here's an example of when we could use congruent triangles. We have something that's otherwise difficult to measure. I can't just stretch a piece of, or a tape measure across the river here. So if I measure the length from M to L, that would be the same as the length from M to P, and then I would know how far it is across the river. Okay, so that would be an example of where I could find use a triangle congruence to get us to where we need to be. Okay, it's a little bit different process, but that's where it could come into play. Okay, let's go over to, I'm going to skip this one. Let's go over to these 2. Okay, for this one here, we saw some like this last week. On Friday, we talked about overlapping triangles, and that's what we've got here. The 2 triangles that we're going to refer to here are going to be these two here. Angle L is congruent to angle O. LMN is congruent to angle ONM. And all of that is given. Okay? And that's the way I typically like to do it. Okay, that is the pieces that are given to us. Okay, as you write it out, make sure that you mark it on the picture. Right now it's not marked on the picture. I also like to separate these two triangles because they're not separated as they are right now. We talked on Friday about when you have overlapping triangles, I think the best way to do it is to separate them. And then mark it on each individual triangle so you can see the pieces that you have a little bit easier. If you try to mark it on the overlapping picture, it gets a little bit confusing because then you try to figure out which angle is marked and which angle is not marked. Okay? So that's why I would encourage you to separate triangles that are overlapping like that. Okay, how many pieces right now on those two triangles are marked? 2. Okay, we got to have 3. Always need to have 3. 2 is never going to be enough. Okay, we say that over and over again. Okay, is there something on those two triangles that we can prove as congruent that's not already marked as congruent? Yeah. Okay. We have a shared side. MN, this piece right here, is the same on both of these triangles. I know the one I drew is a little bit smaller, but you get the idea. MN on this triangle is the same as MN on this triangle. It's the same side. Okay? We don't know the actual length of it, but we know they're congruent. Okay? We know that MN is congruent to MN because of reflexive. Okay? If they share a side, and that side is exactly the same thing, just another example of the reflexive property. Okay, do I now have 3 pieces? So I should be in good shape most of the time if I have 3 pieces. So now we're going to follow the path of the pieces that we have. Here we have, what do we got here? Okay, we got an angle, and a side. Follow the path of the markings. Now, and some people will ask me this question, and it's a great question. Some people say, well, what if I started up here and did the side first? Well, then you have side, angle, and that's not really one of our theorems. But if I just reverse it and go the other way, angle, side is the theorem that we're going to use here. Okay, so the first triangle, we can name it any way we want to name it. So I'm going to go triangle LMN. What piece would match with angle L? O. Okay. What would match with M? N. This is where you got to be careful, right? This angle is M. Over here it's N. So don't just immediately say, oh, M and M match up because they're the same letter. This M here matches with this N over here. Those are the two that are marked the same. And then O, N, M. And we said they were because of angle, side. Okay, so finally, we're not done yet because we're trying to prove that LM and ON are congruent. And once we've identified that the two triangles are congruent, then the two sides are congruent because of? Okay, and that's why the triangles are congruent. And then we're going to use the new theorem that we talked about today. Anytime you're proving a side or an angle congruent, you're probably going to use the CP/CTC. If I'm trying to prove two triangles congruent, like this, we're going to use angle, side, angle, side, HL theorem, one of those 5 ways to do it. And that's what we've done on all the proofs leading up to today. Today we're adding that one step at the end. That's the only difference. Okay, let's try this one here. Okay, as I look at these triangles that are overlapping, is there a shared side on these two triangles? No. Okay, up here, they shared side MN at the top. This was a shared side on the two triangles. If I were to redraw these two triangles, we got this one here. We got this one here, okay? They are sharing MN. Both of those triangles have MN in common. Okay, if I look at this one down here, we got this triangle here. We got this triangle here. Okay, those two triangles are sharing what? They don't have a side in common. What do they have in common? Angle C. Okay, angle C down here is on both of those triangles. Okay, now it's going to be very similar to the proof we just did, but here is what I would do. I would redraw those two triangles. Okay, we're going to start writing out our statements. AC and EC are congruent. Angle A is congruent to angle E. All of that is given. So angle A and angle E are congruent. AC and EC are congruent. When they state this, mark it on your picture, okay? But you got to redraw the picture here. You got to put a little bit of effort in to redraw it. If you don't redraw the picture, it's going to be really hard for you to mark on this overlapping piece right here. What's what, right? You got to take those triangles and you got to separate it. We're comparing these two triangles right now. Take the time to redraw it. If you don't, there's a good chance you're probably going to miss it, okay? I'm just giving you fair warning because trying to identify what you got without redrawing the triangles is going to be a little bit difficult to do. Okay, what we said is these two triangles share what? Angle C, okay? And I don't really need to use three letters here because angle C is angle C. There's only one angle at angle C. Both of those triangles share that angle. So this angle is congruent to this angle because they're the exact same angle. That angle is the same on both of those triangles. Okay, as we look at these two now, how many pieces do we have? Okay, what do we got here? We got three. We got, what is this? Angle, side, and an angle, right? We got three pieces. Is angle, side, angle a theorem that I can use to prove triangles congruent? That's one of my five, right? So here's what we're going to do. Okay, the first triangle. Tell me one way to name this triangle right here. Any order you want. Okay, ADC. It does not matter how you name that first triangle, but when I name the second triangle, all the pieces have to match up. So what's going to match with A? How do we know what matches with A? It has the same angle marking, right? So A is going to match with E. Okay, then we went to D. D doesn't have a marking and B doesn't have a marking, so D and B are going to match up. And then C has two markings, and this has two markings. Okay, and so we would say that those two triangles are congruent because of angle, side, angle. Okay? Here's how we know we're done. Does it tell me to prove the triangles are congruent? Is that what the proof statement says? No, it doesn't say prove the triangles congruent. It says let's prove that AD and EB are congruent. Well, why would we know that AD and EB are congruent? Because of our new statement today. CPC, TC. Okay? If you're proving two sides or two angles congruent, you're going to probably use the CPC, TC. If all I'm trying to prove is two triangles congruent, then you're going to use one of the 5 theorems. Okay? Let's remember what the 5 theorems are. I'm going to write them up here on the board for us. Okay? What's one of them?
Angle side.
Angle, side, angle. Okay? What's another one?
Side.
Side, side, side. Okay?
Angle side.
Angle, angle, side. HL. And one more.
Side angle side.
Side, angle, side. That was the very first one that we did. It's been a while since we do that. Okay? Remember that HL has 3 parts. HL must have a 90-degree angle. Okay? So that's why it only has 2 letters. You have a hypotenuse, you have a leg, and you have a 90-degree angle. Okay? On the rest of them, you're going to have 2 angles with a side in between. You have 3 sides, 2 angles and then a side, or an angle between 2 sides. Okay? So it all depends on where those pieces are at. These are the 5 ways that we can prove a triangle is congruent. Okay? If I'm going to do sides or angles, we're going to do the CPCTC. Okay? That's the part you just have to kind of keep separate for today. That's going to be really important as we move forward, reviewing the next couple of days, and then